Hello everyone. Uh,
The topic, the scalars, vectors, matrices, and tensors. So, what are scalars? As you can see here in this slide, the scalars are nothing but the zero dimensional tensors. So, why zero dimensional tensor? That is, there is only a single real number. As you can see that in the example, x is equal to 1.23. This 1.23 is nothing but a real number, and also it is a zero dimension in nature. Okay, so there are no multiple uh, rows, okay, in this. So there is no dimension added to this number, whereas in the vectors you can see that there are dimensions that are being added. So that is why they mathematically we represent it as r to the power of n. So the linear algebra says that x belongs to r to the power of n, which says that there is n dimension added to the real number. But when you are saying in the neural network, because for the programming notation we have to represent in the form of, we have to give n into 1, r power of n into 1. That means that there are n dimensions. Okay. And into 1 is nothing but, that is how many number of columns are there. So we represent this x over here as x1 x2 up to xn. Okay, so that many features are there. Okay, so for that reason, uh, that many trainings are being done. Okay, so for that reason we'll be mentioning as the x1 to xn. Okay, and one is nothing but the input feature. So for one input, okay, the n training will be done. Okay, one input, the n training will be done. So that is what it is being represented. Okay, same thing for x transpose x, it is represented as x transpose of t. Okay, which you can see here, which is nothing but the trans reverse of this. So that is nothing but, there are multiple rows and single column, and this is represented by x transpose, which belongs to r to the power of 1 into n. That is nothing but there is one feature, okay, to added to n number of um, sorry, one training done to, or one training set to n input features. So something like that you can say. Now coming to the matrix is nothing but the two-dimensional tensors. Okay, they are known as two-dimensional tensor. So here you can say that x1 comma 1, x1 comma 2, it is nothing but this is nothing but first row, first column, first row, second column, first row, n column. So there are, in this way, like that, x m comma n is nothing but m rows and n columns. So m is nothing but number of rows and n is nothing but number of columns. Okay, where you can say that for the matrices, okay, we are actually doing the this is actually represented as n columns, and this is nothing but m rows. The matrix is represented in form of x belongs to r m into n. Now you can see the difference here. I am using here capital X. Here it is a small x. So capital X, it is used that to design a matrix. For designing a matrix, I am actually representing as capital X, and this is actually nothing but normally we are representing as r m into n, where m is nothing but we can say that number of training set, and n is nothing but you can say that this is nothing but number of features, and m is nothing but the number of uh, uh, you can say number of training examples, and n is nothing but input features. So that is what you can see that. So we of usually denote x as, okay, as a x is nothing but a special convention which refers to as the designing the matrix. So to design a matrix, we actually represent it as x, where x is nothing but r to power of n into m, where n and m are nothing but n is nothing but the input features, m is nothing but the number of training examples. Now, n is uh, um, um, here you can say that x is equal to, okay, 1 power 1 or 2 power 1. So here you can say n is nothing but is referred to the number of examples, okay, which I just now told you. And mm, uh, and m is input feature. So feature, and n is nothing but the data set. Okay. Now we can see that here in this case, okay, for example, here they have mentioned x2 of 1. That is nothing but the second feature of the first training example. So this is nothing but the second feature, okay, of, okay, x2, sorry, this one, x2 of 1 is the second feature of first example. Same way, this is nothing but second feature of second example. This is nothing but second feature of nth example, nth training example. Same way, this is nothing but, okay, first feature of first training example, first feature of second training example. This is nothing but first feature of nth example. Okay. So what you can understand here is these are nothing but my the we can say the training example. These are nothing but training example which you can see here. That is x1 of 1, x2 of 1, xm of 1, and this one x1, x2, xm. These are nothing but the feature value. These are nothing but the feature values. Okay. Now, coming to the notation of 3D sensors. So 3D sensors, there is, we can, it is also known as the multiple matrices, you can say. So you can say the x to the power, x belongs to r to the power of m into n into p. That is nothing but the matrix is of m into n, okay, but there are p times m into m. So 3p times m into m, okay, sir. That is nothing but stack of p stack of, okay, m into n matrices are there. So you can see that this is one matrix, this is another matrix which you can see behind. Like that, there are p stack of, okay, m into n matrices which you can see over here. Now you can see this example. In this example, this is a cat, okay, where it is represented in the form of RGB, you can say. So this is nothing but red, green, and blue. So these are nothing but the three color channels. Okay. And this is a cat which is in the 3D tensors. Okay. This is a cat which represents 3D tensor. So there are three color channels that are being given. So you can say that each tensor is of 100 into 100. Okay. 100 to 100 pixel values. This is also red. So red is 100 and green is 100 and blue is 100 to 100 pixel values. Okay. And in in this you can say that three such 100 pixel values are combined together. Okay. And in that way it has been represented. But in deep learning, we don't take this 3D sensor. We actually represent it in the 4D tensors. So what is that 4D tensors? 4D tensors are nothing but is, as I just now discussed, that this is one RGB. Okay, this is another RGB. This is another RGB. This is another RGB. So multiple such RGB 3D tensors. So multiple RGB, that is in 3D tensors. Okay, are being taken. So uh, so in and this is represented as in the form of n, c, h and w. So n is nothing but the how many training examples. So because this whole set which you can say is nothing but the training example, that is number of training example, there are that many training examples we are actually giving. Okay, so you can say that um, this can be this is nothing but the number of training examples, that is nothing but you can um, the total training example along with chw we can put together as m. What is this c is nothing but the how many number of colors. So there are number of colors is nothing but there are three color channels being used, three color channels that are being used. So this is nothing but your c is nothing but with respect to the color channels. Okay, that is rgb. Then h is nothing but the height, and w is for the width. Okay, so the three, so this color channel, then height and width put together, we represent it in the form of m. Okay, so this m, okay, is nothing but the combination of color, okay, height and width. So for each pixel you can say that this color, height and, so this is another color, height and width, this another color, height and width, color, height and width. So this is nothing but my m. Okay, and and into n is nothing but this many training examples. So this is nothing but n training, for n training examples. Okay, and m is nothing but the features, you can say. So we can say that this this feature itself is a three dimension, okay, in nature, because this is a color is of three dimension, then height and width of this three dimension. Okay, and we are taking the one more dimension, that is nothing but the number of training examples. So this it is making the four dimensional tensors. Okay, now uh, in the context of TensorFlow, okay, NumPy, PyTorch, okay, you can say that the tensors. So tensors are nothing but the how in mathematically, in mathematically we are mentioning the rows, columns, sorry, the vectors, matrices, okay, and tensors as as we 3D tensors as a tensor. Whereas in the in programming, when we are talking the programming point of view, the same tensors are mentioned as multi-dimension arrays. You know, for example, a matrix, okay, or the vectors, we say it as a multi-dimensional arrays. We don't say it as a tensor in the programming. So that is why we mention it as a multi-dimensional arrays. Now in the TensorFlow, okay, we mention these multi-dimensional arrays as tensor. Okay, for NumPy we see it as an ND array. For PyTorch we say it as a tensor. Okay, now if you can look at this example, okay, so we can say that this is a dimensional coincide with the number of indices dot shape. So here we are using the PyTorch here. So that is why I import PyTorch, and this is nothing but the multi-dimensional, okay, a tensor we are using here. So this is nothing but, you can say, one matrix. This is nothing but first row and second row. So there are two rows, 1 2 3 are nothing but the number of values in that particular first row, and this is nothing but second row. Okay, now so t is what I have mentioned as torch dot tensor, okay, is a function which is being used. So here we have to mention, okay, what it is telling the what is the shape of it. Okay, So this tensor is of what dimension? Okay, that we have to mention. So tensor is if I giving this input as t, I am getting the output as tensor of 1, 2, 3, and 4, 5, 6, which is nothing but this is nothing but my okay the first row and second row. Okay, and how many columns are there? There are three columns. So that's what. So when I say it as t dot shape, it says that there are three columns and two rows. That's why it is saying 2 comma 3 over here. This is nothing but two rows and three columns. Okay, so two rows and three columns. So that is what the size of the tensor it shows. Now when I say what is the dimension, n dimension for this particular tensor, so that is tensor is something but a t. Okay, so what is the dimension? So we can say the how many dimensions are there? This is nothing but first row and second row of this particular size what is being mentioned of this size function. So we can say it as a this is one dimension and the another dimension, two aspects we have taken. Okay, so because we are not taking it as three dimensional, so only two dimension, that is two rows and three columns. So there is nothing but x and y we are taking into consideration. Okay, x and y we are taking into consideration. So that is nothing but there are three columns and two rows. Okay, so two is nothing but my x values. Okay, and three is nothing but the y values. So that is why how many dimensions are there? This is one dimension, another dimension. So totally two dimensions are being considered. Okay, so that is why when I say t dot dim, n dim, it is showing two. So to sum it together, this is nothing but the how the representation of scalar is. So this is a real number which I am mentioning. Okay, this is a zero dimension and just a real number. Whereas for the vector is represented as one dimension. Okay, you can see that um, uh, the x of 2, that is nothing but an array represented as x. This is nothing but x of 0, this is x of 1 and x of 2. This is x of 0, x of 1 and x of 2. So x of 2 value is equal to 5. So you can say that this is nothing but the third row value of the one column. So and as I said, this is nothing but in the form of okay 3 into 1. Okay, that is nothing but there are three rows and one column. Whereas in this case, you can see that when I say x 1 comma 0, that is nothing but 0 and 1 and 0. So this one is nothing but the number of. So you can say that this has 0, 1, 2, and this also has 0, 1, 2. So 1 comma 0 is nothing but this is 1. Okay, and this is nothing but 0. Okay, so that is this is the first row and 0th column. So we start with 0. Okay, index is starting from 0, not from 1. So when I say 1 comma 0 means this is nothing but 0 and 1. One first row what and 0th column. So which value is that? That is 7. So 1 comma 0 is equal to 7. This is nothing but 2 times. Same way for tensor 0 comma 2 comma 1. So here you can see that there are three aspects that are being taken into consideration. Okay, so 0th row means this is my 0th row. Second 2 is nothing but second column. Okay, so you can say this is 0, 1, 2. So I can say this is the second column, and 1 is nothing but the z axis. So you can see the 0th row, okay, second column and first. So that is nothing but the first matrix of the tensor, multiple tensor. Okay, so you can say that this is the if it was 2, that means it would have been the value which is behind this matrix. But this is the 0th row, second column and first. So this is the whatever the first value what is there, okay, which is the behind one. Okay, so that we can say it as the phi as the value. So here z value is 1. Okay, here you can say x is nothing but 0, y is nothing but you can say that this is 2, and z is nothing but this particular one. So z is equal to 1. So this one is, the front one is z is equal to 0, and the second one is z is equal to 1. So in the z is equal to 1, behind, okay, the what value is present, okay, so 0, 2 and 1. So behind this particular matrix, whatever the value is there, so that is nothing but equal to 5. So this is about the 3D tensor. When it comes to multi-dimensional tensor, so it's more complex in nature, because it is not 2 dimensional, 3 dimensional, 4 dimensional. It is much more complex. So that is why you can say end data end. So it is bit we have to dig deeper. So that is why it is looking like gibberish over here. Okay, that's it. So anyway, so that's for this topic. So if any queries, you can ask. Thank you.